Hi, I'm Alex, and in this video we'll build a circuit you've seen in lecture using Logically, which is the program that you'll use in your problem set to build circuits. So this is the way you've seen circuits drawn on the lecture slides. Logically uses the same symbols for all the logic gates, but there are some other differences. So first let's review the gates in this circuit. I've redrawn the circuit in kind of a way that Logically will draw it, although we'll see in a bit there are some other differences. So we've got two NOT gates here, we've got two AND gates, we've got one OR gate, and then we've got our inputs and our outputs. Our inputs here we've just designated with X and Y over these wires on the left, on the top left. And then over here we've got an output pin on the right, or the wire that's the output wire on the right. So in Logically, we're not going to just show the inputs as just letters over wires, but we're actually going to show inputs as switches. We're going to show outputs as light bulbs. And then another thing with Logically that's different from our lecture slides is that when we have a component that has a value of 1, that component will have some blue color. And then when we have a component where it's 0, they're going to be white. So in this case, you can see already there are some wires here that don't have any input. They don't have any 1 values, so they're white, which means they're 0. And then this NOT gate, for example, its input is 0, so its output is 1, which is why the wire here is blue. Okay, so let's actually build this circuit in Logically. And you can see Logically presents as a single window where on the right we've got this grid, which is where we're actually going to drag in our components and position them and position their wires. And then on the left we have what Logically calls the object picker, which is just kind of a library where we choose different components. So you can see we already have our toggle switch here, we have our light bulb, we have our logic gates down here, we have our NOT gate, our AND, and our OR gate. These other gates we're not going to be using in the problem set, we're not going to be talking about them. And these flip-flops too, we're also not going to talk about them, so I've collapsed them here by pressing that button. So to get started with our circuit, we know we're going to need 2 inputs, so we're going to need 2 toggle switches. And then we also know we're going to need a light bulb. That's our output, our single output. So we can also drag out our AND gates, our 2 AND gates, our 2 NOT gates we know we're going to use, and our single OR gate. Now to start connecting these things together, we're going to start making connections. So to make a connection, or a wire, you're going to start at some particular pin of one component. This is the toggle switch's output pin. And this is the input pin of the NOT gate. So what we're going to do is we're going to click and drag on this pin. And you can see as we're clicking and dragging, all the other pins in the circuit that could possibly take that particular input turn light blue. So that just tells us where we can go. In other words, we can't attach something to the output of a gate since we're bringing something in from a switch. So we're going to actually let go on top of that NOT gate. And then for this input, we're going to click, drag, and then let go. And then we're going to do the same to actually bring the outputs of the NOT gates into this AND. And then the same for the AND into the OR, and then for the OR into the output light bulb. Okay, so you can see, as we saw before, the circuit diagram actually gets updated with the particular value that's on the wire, and we can see that the light bulb itself is blue. So a quick note on another type of state you can see. Wire can be white for 0, and it can be 1 it can be blue for 1, but it can also be red in the case that the wire doesn't know what state it should take. So if I actually click on this wire by just clicking on it, and I delete the wire by hitting this delete selected object, or I can just press backspace, what you'll see is that all these wires here turn red because it's unknown what their state should be. The reason why this wire is red is because this NOT gate has no input. So in other words, it doesn't know whether to output 1 or 0. And then by extension, the output of this AND gate is red because one of its inputs is red. And that follows all the way down to the output. So you can see if you have red, that means that any one gate before this wire, for example, anywhere along this chain is undetermined. Okay, so to finish up, we're going to reconnect this. And then I'm also going to draw, again, what I need to do is I need to draw from the X and the Y, our inputs. I need to also draw into this output, into this AND gate. So I'm going to click and drag from the same output pin of the input switch, the toggle switch. And I can do that as much as I want. I can drag as many times as I want from a particular output pin on a particular component. And then I'm going to connect this up here. Okay. So and if I want to actually test this particular circuit, I can just click on the input switch, and I can turn this first input to 1, and the second input I can also toggle. Alright, so one more thing I want to mention, and that is that what you'll see with our starter files for the problem set is you'll see that we're going to put the NOT gates next to the input switches. That way you can draw from both the input switch's value, and the NOT of the input switch's value. So I'll show you kind of how we're going to do that. So what we're going to do is we're going to actually rotate these components, which we can do by just clicking on a component and clicking on rotate. We can actually rotate these switches, and we can make it look more like kind of how it appears in the lecture slides by rotating the switches and then by putting the NOTs of those switches next to the switch. So I can do this. I can rotate it and put it here. And then here I can do the same thing with this NOT. So what you'll see in the starter files is that we give you kind of this configuration by default. And this more naturally this matches our lecture notes a little bit more. Now, we talked about rails in lecture, that is drawing out the wires from both the input pins on the diagram and the NOT of the input pins. For example, something like this where you could draw the wires all the way down. But logically we can't do that because a wire actually has to end up somewhere for it to be on the diagram. So you can see it just appears when I let go of it. But this type of configuration more closely matches what you're used to. So although you can't make rails here, you can put the NOT gate next to the switch, and you can draw from both the NOT gate and the switch. Okay, so that's implementing a circuit using logically.